So for the first one, we all know how to convert feet into inches, but I'm going to go through the process anyway. We've got 7 feet. We're going to put it over 1. Get rid of feet. We're going to put them on bottom. 1 foot is 12 inches. So the feet cancel out. 7 times 12 inches is 84 inches. On bottom, 1 times 1 is 1, so that's just 84 inches. Again, most of us know a shortcut. You just multiply by 12 to get from feet to inches. For metric, we either have to have the unit chart in front of us or have it memorized. We've got meters in the middle of that chart, decimeters, centimeters, and millimeters. And those are the units we typically use the most of anyways. Going from meters to millimeters is 1, 2, 3 spots to the right. So we take our decimal point and we move 1, 2, 3, filling in those zeros, spots to the right. So that becomes 4,700 millimeters. Number 3 is where we have to be careful. That is not inches and feet, it is square inches and square feet. So let's set it up, 3,456 square inches over 1. Put the square inches on bottom, so they'll cancel out. 1 square foot is how many square inches? There we go, 144. That's 12 inches in a foot, so when it's square inches and square feet, it's 12 squared, or 144 square inches. So now the square inches cancel out, we multiply. 3,456 times 1 square foot is 3,456 square feet. And on bottom, 1 times 144 is 144. We divide to get 24 square feet. Good. Number 4, 8,600 millimeters squared going to centimeters squared. So again, we're on the metric chart. From millimeters to centimeters is 1 spot to the left. But this is not millimeters and centimeters, it's millimeters squared and centimeters squared. Good. Since it's squared, what does that mean for every spot on the chart? Instead of 1 decimal place, it's 2. So 1 spot on the chart is 2 decimal places. So we go 1, 2 decimal places to the left. That's just 86 centimeters squared. So the moral of the story there is make sure you're very careful looking at those units to catch if it's squared or if it's just regular units, like these were. For 5 and 6, just some basic operations with our measurements. Subtraction here, we just like any other set of numbers, we start on the right and work our way back to the left. 4 inches minus 9 inches can't be done, so what do? Borrow from the 9, that becomes 8 feet, and what does the 14 inches become? 16 inches, good, we borrowed 12 inches. Now we subtract 16 minus 9 is 7 inches, and 8 minus 3, 5 feet, good. So 5 feet, 7 inches. Number 6, multiplication. Also, we start on the right and work our way back to the left. What's 3 times 9 inches? 27 inches. Perfect. That's more than a foot. In fact, it's 2 feet, 3 inches, like you said. Good. So we're going to keep the 3 inches, carry the 2 feet. 3 times 5 is, careful, 15, plus the 2 is 17. So 17 feet, 3 inches. So we can convert our measurements, our length measurements. We could do operations with them. Today we're going to move on. We did actually conversions with our units of area as well. So today we're going to actually talk about finding areas and calculating areas. So to talk about what an area is, we talked a little bit last week about the whole geometry, starting from a point and using that point to basically build all of our other features in geometry. We said an area was a length that has been moved through a distance. And that distance is always measured at a perpendicular. If it's a rectangle, of course, that distance is just the width of the rectangle. We had a rectangle that's 15 inches by 6 inches. How do I find the area? Yeah, 6 inches times 15 inches, which gives us 90, and of course, inches times inches is inches squared, square inches. If it's a parallelogram, let me make that actually look like a parallelogram a little bit. Let's say this up here is 18 inches, and this here is 10 inches. Do I do 18 times 10 to find the area? Okay, so for this one, for a parallelogram, to find the area, am I going to do 10 times 18? Say no, why not? Yeah, we have to have, for area, we have to have two dimensions that form a right angle. So if I tell you that this here is 8 inches, now how do we find the area? 18 inches times 8 inches, good. To get 144 inches squared, perfect. The one that's a little trickier, if you remember the trapezoid, let's say we've got 14 inches here, 15 inches here, and let's do 30 inches down here. Do you remember how to find the area of a trapezoid? Careful, you're close. It's the average of the bases. You add the two bases together and divide it by 2, and then multiply by the height. So 14 and 30 add to 44. So you got 22 times 15, perfect. So 330, and of course these are in inches, so that is inches squared. So if we have a right triangle, this is 21 inches and this is 8 inches. How do we find the area of that? There we go, 8 times 21. And then because it's half of that related rectangle, it's divided by 2 to give us 84 square inches. What if it's not a right triangle? Let's say I tell you that this is 30 inches across here. What dimension do I need to go with that? The vertical, the altitude is called, right? From that opposite vertex down to that 30 inches. So if I tell you that that is 9 inches, how do I go about finding the area then? 9 times 30 divided by 2, perfect. Which gives us 135, good. Of course, that is inches squared. And we looked at circles. What's our formula for circle area, by the way? Pi r squared, good. Pi times radius squared. So if I tell you that this is 5 feet here, my area is pi times 5 squared, which is we'll call it 78.5. If I tell you I have a circle with a diameter of 16 inches, how do I find the area? Perfect. 16 divided by 2 gives us an 8-inch radius. So it's pi times 8 squared. Good. Which is? Perfect. Yeah, if you use the 3.14 for pi, it's 200.96. If you use the pi key, it's like 201 point something. Sure. Okay, so today what we want to concentrate on is what happens if we have combined shapes, or shapes that are not just straightforward. We'll start out with something relatively simple. So let's say that this is 20 inches by 28 inches. I'm going to give this piece up here 16 inches and this one here 14 inches. There are two ways to find the area of a shape like this. One is to divide it up. Oh, I can't spell today. And add the pieces together. What do I mean by that? Well, I can either cut it across here or I can cut it across here. And I have two pieces. So let's leave it cut like this. The area of that first piece was just 20 by 16. Perfect. So 320 square inches. The second piece, we know this is 14. What's the other dimension? 12. Good. Yeah. 28 minus 16 is 12. Which is 168 square inches. So we just add those together to get a total 488 square inches for that area. Perfect. The second method is to fill in the missing pieces and then subtract. Well, what do I mean by that? Well, there's just this little corner missing. If I fill that in, I have a complete rectangle, and the size of that rectangle is what? 28 by 20. You got it. Which is how much? $560 square inches. Good. But now we've got this rectangle that really isn't there. It's 12 by, what's this dimension here? 6. Good. Perfect. 12 inches by 6 inches is 72 inches squared. And it's missing, so we have to subtract that out, which leaves us with 488. So we get the same total area either way. In a problem like this one, it's about the same amount of work either way, whether you cut it into small pieces or whether you fill it in and subtract it back out. But there will be different problems where it is more or less work one way or another. For example, I might have a problem like this. For something like this, it's probably easier to cut it into small pieces and add those areas together. So I cut it across here and here. I'm just going to label them 1, 2, and 3. How do I find the area of piece 1? Oops, get back here. 12 times 3. Perfect. 12 feet times 3 feet. 36 square feet. Piece 2. Well, we have the 6 feet. What's the other dimension there? So that's 7 feet. Perfect. So yes, 6 times 7 is 42 square feet. Piece 3, we've got the 14. What is this dimension here? 17. Good. The 7 is still here, plus the 10. So that is 14 feet times 17 feet, or 238 square feet, We add those all up. 316? Perfect. So we have an area of 316. We might also have something like this. What do I put there? Something like this, it's probably going to be easier. I mean, if we try to cut that up, because none of these corners line up, we have to cut it something like that. They've got some really weird dimensions to try to find. This one's probably easier to fill in than subtract out. Now to fill it in, we have to figure out what this overall dimension is. What's it going to be? 50, good, just the 40 plus the 10. And this overall dimension will be 27, looks correct. So that overall size, 50 inches times 27 is what? 1,350 inches squared, good. Now we have to subtract, this piece here will be pretty easy to find. How do I find that area? 5 times 10, good, which is 50. I'll subtract that out to give me 1,300. This one's pretty easy to find. 6 times 10, which is 60, so yes, 1,240 now. This piece is going to be a little bit more work. We have to find some dimensions there. Okay, yeah, so for this one, you're right, it's 27 minus 8, which is 19. Up here, it's going to be 50 minus 34 and 6, right? So it's 10 inches, perfect. You got her. 19 times 10 is 190, which gives us 1050, 1,050 square inches for area. Not simple either way, but it's probably easier to go that route than it is to try to cut it up and piece them back together. Some of them absolutely have to be done one way or the other. Like when we start throwing in circles with some of our pieces. So something like this where we have a rectangle, let's do, oh, I'll try not to be too tricky here. Something like this. We might be looking at it and saying, well, we don't know the width of that rectangle, but we do. We know that this dimension here is how much? 4 feet. So that is the radius of my circle. Well, 4 inches, I should say. And the radius of a circle goes in every direction. So if it's 4 inches there, it's 4 inches here, which means the diameter is 8 inches. So that rectangle is 8 by 16 or 128 square inches. So that's this piece. The second piece here now is not a full circle, it's half a circle. If I wanted to find the full circle, it'd be pi times 4 squared. Half a circle, so we're going to divide that in 2, gives us, perfect, 25.12. We add those together to get 153.12. Perfect. Similar to that would be something like this. So let's say that's 20 feet, and we'll go 10 feet across here. This one, we had to find the areas and add them together. This one, we have to find the bigger piece and subtract out that half circle that's missing. So how do we find the area of the big rectangle? Oops. 20 times 10, good. That's 30, oops, not 30, 300, 200. Wow. Some days the internal calculator doesn't work so well. So 200 square inches. How do I find the piece I have to subtract out there? Okay. We divide by 2, perfect. So that comes out to be 39.25. And that does have to be subtracted. Perfect. So we get an area of 160.75. What if I asked you to find the perimeter? Perimeter, remember, is just adding up all the sides. So for this one here, I'm just going to pick a point and go around. I've got 16 plus 8 plus 16. You got it, the circumference. That's circumference is pi times diameter for circumference, right? So it'd have to be the 8, but it's only half a circle, so divide by 2. So it does end up being 5 times 4. But so that comes out to be, oops, get back here. 6.28 seems a little small. I was thinking 12.56. Pi times 8 divided by 2. 12.56, good. So what does that add up to? Is that 52.56? So there's our perimeter. This one here, the perimeter is going to work the same way. We're going to pick a spot and work our way around. It's 20 feet plus 10 feet plus 20 feet plus, how do I get that? We don't have to subtract. It's for perimeter, it's still adding on to it. It's subtracting out the area, but it's still adding on to the distance around. But it is circumference. Yeah, pi times 10 and then divided by 2, or pi times 5, yep. Which is 15.7. You got her. So 65.7 feet of perimeter. So as we look at these circles as a tool in finding areas, they're actually a very powerful tool in finding those areas because they allow us to transfer dimensions from one direction to another. Let me show you what I mean by that. We'll do this. So that's a quarter circle missing out of the corner of this rectangle. Let's say that's 20 feet by, got my settings screwed up on me here. There we go. 20 feet by 28 feet. And then I tell you that this here is 12 feet. We don't need it for the area, but we will need it for perimeter. What is that distance there? Yeah. You had the right idea though. Careful. Let's work through it. What's this distance here? 8 feet. That's just the 20 minus the 12, right? If that's 8 feet, this radius also has to be 8 feet. So there you go. 28 minus 8 makes that 20 feet. For area, we're going to simply find the area of the big piece. 28 feet by 20 feet, which is 560 square feet. How do I find the area then of that quarter circle that we're subtracting out? Eight squared divided by 4, because it's a quarter circle. $50.24, good. We subtract there, we get 509.76, perfect. Square feet. Not so bad? Well, I'm going to throw a challenge out there at you. What if I give you a circle, a triangle, and I don't give you any right angles, but I give you all 3 sides of the triangle. Can we find its area? Some books call it Hero's formula, others call it Huron's formula. There's a Greek mathematician named Huron. For some reason, some books shorten it to Hero's formula. But what Huron invented was a way to find the area of a triangle without having any right angles, by just knowing the 3 sides. And the process, step 1, was to find the perimeter. How do I find the perimeter of this? $30 inches? Okay, we just add them up to get 30 inches. Step 2 was something called the semi-perimeter. The semi-perimeter, S is just the perimeter divided by 2. Yeah, 30 inches divided by 2 is 15 inches. If you label the sides A, B, and C, where A is the smallest side going up to C being the largest side, the area, this is kind of an ugly formula, is that semi-perimeter, the square root of that semi-perimeter times the semi-perimeter minus the smallest side times the semi-perimeter minus the medium side times the semi-perimeter minus the longest side. So if we put some numbers in there, that's the square root of 15 times 15 minus 5, that's the smallest side, times 15 minus 12, that's the middle length side, times 15 minus 13. So that's the square root of 15 times 2, or times 10 times 3 times 2. What's that come out to be? What was that? 900? Okay, so you still have to square root it then. Ah. Come up to 30, right? So the area is 30, the length for inches, square inches. That comes up to be 30 square inches. This is actually a right triangle. If it wasn't a right triangle, it would not have come out to a nice, neat number like that. It would have been an ugly decimal. So one of the things we need to be able to do is we need to be able to test to see if it is a right triangle. To throw out another one of those Greek names, Pythagorean. Okay. Yep. So the Pythagorean theorem says if you have a right triangle, the two legs, now the legs are the two shorter sides. They're also the two sides that make the right angle. Think of right angle as an L, so the two sides that make the L are the legs. The other side that is opposite the right triangle or the right angle is the hypotenuse. Hypotenuse is always the longest side of the triangle. So the Pythagorean theorem or the Pythagorean rule is a squared plus b squared, where a and b are the two legs, equals c squared. So we can test here to see if that's true. 5 squared plus 12 squared. Check to see if that is 13 squared. Well, 5 squared is 25. 12 squared is 144. That adds up to 169. And of course, 13 squared is 169. So that is a right triangle. So we could have saved all that work by testing to make sure that's a right triangle. So in your notes, I want you to tell me, is that a right triangle? So if it's a right triangle, what two sides would have to be the legs? 7 and 24. So we go A, those are A and B. So then the hypotenuse would have to be the longest side. So 25 we'll call C. So A squared plus B squared has to equal C squared. So 7 squared plus 24 squared has to be 25. What is 7 squared? 49. 24 squared? 576. That adds up to 625. What's 25 squared? 625. Okay, it is 2:21. It is time for break. So let's come back at 2:31. So we've looked at those strategies for finding areas of complex figures, and we've looked at that Pythagorean rule. Let's now take a peek at, let me do this. I'm not going to tell you that, I won't tell you that this is a right triangle. You're going to have to figure out whether it's a right triangle on your own or not. Somebody give me a number between like 5 and 20. 8? So make that side 8. Find the area of that. So the first question, is it a right triangle? No. What would be the legs if it were a right triangle? The 8 and the 15, right? The two smaller ones. The hypotenuse would have to be the bigger side. So we typically label a triangle from smallest to largest. That'd be a B, not an A. Just because of that, so that if it is a right triangle, that hypotenuse is labeled C. So 8 squared plus 15 squared, compare that to, I'm not even going to put an equal sign in there. Let's compare that to 18 squared. What's 8 squared? 64. 15 squared? 225. We add those together, 289, right? What's 18 squared? 324. So it's definitely not a right triangle. So how do we find the area? Well, yeah, here, well, Pythagorean theorem is what we use for the angles. Hero's formula, Huron's formula. So the perimeter, how do we find it? Perfect. 8 plus 15 plus 18, which is 41 inches. What's the next step? Semi-perimeter. We divide that by 2, which is 20.5 inches. Next step? Okay, so it's the square root of that 20.5 times 20.5 minus 8 times 20.5 minus, what was it, 15 and 18? Minus 15. My inking's moving on me. And then 20.5 minus 18. So this is the square root of 20.5 times 20.5 minus 8 is 12.5. 20.5 minus 15 is 5.5. And 20.5 minus 18 is 2.5. So the square root of 20.5 times 12.5 times 5.5 times 2.5. Did you get 59.36? Those were in inches, that would be square inches. Not so bad. You okay over there? It sounds like a fur ball there for a minute. Okay, so something like this parallelogram. We know we're given that this is a right triangle here. So to find this height here, we can use the properties of a right triangle. We're just going to call this AB, and of course, the 41 would be the hypotenuse. The formula is A squared plus B squared equals C squared. Well, A is 9. That's 9 squared. B we don't know. That's what we're going to try to find. C is 41. So we're going to do 41 squared. What is 9 squared? 81. We can't do anything with B squared. 41 squared? 1,681. Now to figure out what B is here, we're going to have to subtract the 81. To get B squared is 1,600. And then to get B, we would square root. What's the square root of 1,600? 40. Now we know that's a leg, so it has to be shorter than the hypotenuse. So we better get something shorter than 41. So we get the 40, and that sounds reasonable. So now the area of this is found by doing what? Yeah. Length times width, right? Those are right angles now. So we can just multiply the 40 times the 50. It's 2,000 square inches. Does that make sense? So we can use that Pythagorean theorem to find missing dimensions like that if we can form right triangles. One of the more extreme examples of that would look something like this. Yeah, close enough. For a trapezoid, I want to find the area and the perimeter. For area, it's the average of the bases. Well, I have 30 and 51. So I'm going to add them together and divide by 2, but I don't know this height. How can I find that height? There you go. We can work backwards. A squared plus b squared equals c squared. Well, we can do c squared minus b squared equals a squared, right? Go backwards with it. We have the 10 squared minus, which one? 6 squared equals b squared. What does that come out to be? I'll give you a minute to do it. Perfect. Then you got to square root it, right? Ten squared is, there you go. 10 squared is 100, 6 squared is 36. We subtract, we do get 64. Now on your calculator, if you get that 64 and you gotta take the square root, rather than typing it back in, because yours works the same as this one does. I can turn on, there we go. So you have 64 in there, you can just do this, second square root, second answer. So it'll take the square root of the previous answer. So you don't have to type it back in. So yes, we take the square root of that, the square root of 64 is 8. So that is saying this is 8 inches. So our area is that 30 plus 51 divided by 2 times 8. What's that come out to be? (324 square inches). Perfect. For perimeter, well, we're going to add some sides together. We got the 30 inches up here, plus the 10 inches here, plus the 51 down here. We still need that side. What do we know about that side? If I cut that, what do I know about the length of that red line? It's 8 inches. Do I know this length? Well, I know this has to be how much? 30 inches. Good. So I got 51 minus 6 minus 30 is 15. Good. In your notes, find the length of that side for me. So for this one, we know both legs and we're looking for the hypotenuse. So it's just a squared plus b squared equals c squared. 8 squared plus 15 squared equals c squared. I'm not going to do it out by hand. I'm just going to punch it in the calculator. What I'm going to do is I'll put in the square root symbol first. Then it's 8 squared plus 15 squared. Close off the parentheses for the square root. That gives me that is 17. Bless you. So C is 17 inches. So we add 17 inches to this. Gives us a total of what? 108 inches of perimeter. Perfect. So when we're dealing with those right triangles, we have two possibilities if we're trying to find a missing side. Somebody give me a number between 6 and 20 again. 17, okay. So 17. We might have the missing side here is what? A leg or a hypotenuse here? Hypotenuse. When we're missing the hypotenuse, we're just going to do a squared plus b squared equals c squared. So we'll have the 17 squared plus 144 squared equals c squared. What's 17 squared? 289. 144 squared. 20736. So we add those together, we get 21,025. And that's c squared. So how do we find c? Square root it, and that's what, 145? So we can find that length there, 145. The other case, somebody give me another number between 6 and 20. I heard 12. We'll use 12. You got to say one earlier. We're missing a leg rather than the hypotenuse. So in this case, if we're missing a leg, we're going to use c squared minus a squared equals b squared. So the hypotenuse would be the 37 minus the leg of 12 equals that other leg. What is 37 squared? 13,069? 1369, okay. 1,369. 12 squared? 144. We subtract those to get 1225. So b squared is 1225. We square root to get 35 equals b. So that leg is 35 inches. Not so bad? We're going to give you a little bit of work time here because I haven't been giving you any work time at all in class. Homework, there's going to be 2 sections today. First is a little book. It is units 24 and 25. The odd numbered problems there. And I'm going to give you a packet here in just a second. In this packet, the pages 144 through 147 and pages 156 through 157. The problems on the packet are in kind of like gray boxes, and they copied really poorly. I apologize for that. It might be a little difficult to read, but these are really good problems. Very construction based. So I'll pass out the packet to you quick as you guys get started on those. Let's get back.